What's up, guys? This is your final exam review. So let's go ahead and go over it. I did this in class, but this is just a video for your viewing pleasure, just to make sure that you know what you're doing here. So let's look at number one, the depth, y meters of seawater in a bay, t hours after midnight may be represented by this function. So this is a periodic function. We can see it's a cosine function, and they have constants a, b, and k. We have to figure them out pretty much because that's what they're going to ask me to do. The water is a maximum depth at 14.3 meters at midnight and at noon, and it is a minimum depth of 10.3 at 6 o'clock in 1800 hours. Alright, so I'm going to do a little sketch of the graph then. And I know that that we have a minimum depth here of 10.3. That's what it says. I'm going to have a maximum depth up here of 14.3. I'm just getting this from here and from here, just reading this information. So we're going to say right here, we're going to make this your midnight right here, midnight. And then we're going to go to 6. And then we're going to go to noon. And then we're going to go to 6 p.m., also called 1800 hours in military time. So it's going to have a maximum depth at 14.3 at midnight and noon. So right here, we're already at midnight, and at noon, we're going to hit the maximum again. We're going to have the minimum depth at 6 and at 18. That's what it says. So the minimum is at 10.3, so we're going to be right here and right here. So what we end up getting is a graph that looks something like this. And there's going to be a center line through the middle of it. And that should be situated right between 10.3 and 14.3, which is 12.3. And that's that. Now, the center of this graph typically will be at 0 at the x-axis. That's where the cosine graph usually is. But since this thing is shifted, the center line is shifted from 0 all the way up to what? To 12.3. That's the value of a. This is the vertical shift because we're adding it to the periodic function. So that's what's being added right here. So this a value is in fact 12.3. B is given by the amplitude, this number that you're multiplying by cosine. Sometimes they call it b, sometimes they call it something else. It doesn't really matter what it's called. It's just the number that's being multiplied by cosine. And that right here we can find from measuring this distance from here to here, which is the same from here to here. Okay, this distance here is from 12.3 to 14.3, so this distance is 2, and that's the value for b. That's the answer there. Alright, let's go down here a little bit. Let's find the value of k. Alright, so it's important that you actually take a look at this. This is some number, whatever this number is, in front of t. Okay, and what we're going to basically say is that the period is equal to 2 pi divided by whatever this number is, and this number is 2 pi over k. So this is actually a fraction, 2 pi over k. Alright, it's worth noting though that when you divide by a fraction, you're multiplying by the reciprocal of the fraction. So we're just going to multiply, we're going to ignore this right here, and we're going to multiply by the reciprocal, which is flipping these basically, and multiply. So this 2 pi and this 2 pi are going to cancel, and this is equal to the period. But this period is measured from peak to peak here, and this distance is from midnight to noon, from here to here, right? Midnight to noon. So that distance is 12 hours. So I'm telling you, this k right here is equal to the period, but this period is in fact equal to 12. So that means k is equal to 12. That's pretty much the answer we got in class, just to make sure you know what's happening. So here are all three of your answers for number 1. And it's a piece of cake. Alright, so we go down to number 2. Determine the constant term on the expansion of x minus 2 over x squared, everything raised to the power of 9. This is called a binomial, and we're going to expand it, so this is a binomial expansion. This is why it's called that. So we're going to use what is called the binomial theorem. I'm going to go ahead and sketch it right here. A plus b all to the power of n equals sigma in k equals 0. We got in combination with k, a to the power of n minus k times b to the power of k. Alright, so this is some term in the expansion, and then we're going to add a bunch of terms, which is what the sigma is for, and we're going to add a bunch of terms to make the expansion. this power here is 9, so we can expect probably 10 terms in this expansion here. So one of these terms, though, out of these 10 is a constant term. What that means then is that it's going to equal some number times x to the power of 0. Recall that x to the power of 0 is the same thing as 1. So 1 times any number is just a number giving you a constant as a result. But what this is equal to is this portion right here. Okay? I'm going to say I don't really care about this part in choose k. I don't know what that means for us because we don't care about the number in front of these, okay? Not now, but I'll just write it for now just to show you what I'm doing. So I'm going to say n choose k. Keep in mind the value of n is actually this right here. It's 9. So I can go ahead and write that if you want. 9 choose k. A, this thing right here, is actually this coefficient right here. Not coefficient, just x if you want to call it that. And it's going to be x to the power of n minus k. Recall that this n is actually the same thing as 9. So this is 9 minus k. Times b. b is this part right here, the second term. That's what we're doing here, the second term. And I'm going to rewrite this instead of a fraction. I'm going to write it as negative 2 times x to the power of negative 2, since it's the same thing. And we're going to raise this to the power of k. And I have no idea what that is yet, right? So this is what I'm telling you. Anyway, this is equal to some number times x to the power of 0 because this will yield a constant term that I want. So we're just going after one term in this expansion. I don't care what this number is, okay? I don't need this to know what this number is to find the value of k. K is only associated with the exponent of x. That's the only one I really care about. So I'm going to ignore this. This is just going to be a number, so I'm going to ignore it. I don't care about this. I now have x to the power of 9 minus k, so that's still a variable, x to the power of 9 minus k. This is going to be negative 2 to the power of k. We're raising this negative 2 to the power of k, so this is times negative 2 to the power of k. And then it's also times x to the power of negative 2 times k. We got to multiply this stuff. So negative 2 times k. And this will equal some unknown number that I don't care about, right? Raised and times x to the power of 0. I don't care about this number. This is just a number. Negative 2 raised to some number is another number. I don't care about the numbers. I only care about the x's. That's the one thing I'm interested in. When you multiply x's, you add their exponents. So I have 9 minus k plus negative 2k. What this is going to give you is x to the power of 9 minus 3k. And this will equal x to the power of 0. That means that 9 minus 3k is actually equal to what? Is equal to 0. If 9 minus 3k equals 0, that means 3k is equal to 9. If you rearrange that equation, and that means k is of course equal to 3. This is not your answer, but it's going to help you find the answer. We're going to use this value for k to get the actual answer itself. So what I'm going to say then is I'm going to pay attention to just this part. I don't care about adding all the terms. I only want one term, and that's the constant term. So I don't need to add all the rest of them. Okay, so what I have here is n choose k. Remember this. Now I know that k is 3. I already know that n is 9 because I told you up here. Let's go ahead and use this. So we got 9 choose 3, which is the combination here, right? We got a right here, which is actually the same thing as x. So this is going to be x to the power of 9 minus 3, which is x to the power of 6. And then we got this here. Remember that negative 2 raised to the power of 3. So what we're going to say is multiply this by negative 2 to the power of 3. Okay? And we're going to multiply that by x to the power of what? Of negative 2 times 3. Negative 2 times 3 is negative 6. And this is what we're after. Okay? This right here, this part right here, what this means, if you recall from class, it means 9 factorial over 9 minus 3 factorial times 3 factorial. Okay? I suggest you just do that in a calculator. What you're going to find that is actually going to be 84. Is what that is. Okay? So what I'm going to say then, this part right here is 84. Okay? So I'm going to write it over here actually. 84, and then we got x to the power of 6. Negative 2 raised to the power of 3 is in fact negative 8. So this is a negative 8 we're multiplying by. Negative 8. And then we got this right here, x to the power of negative 6. When I multiply these, I add the power, so it's going to give me x to the power of what? 0. That's what I was expecting. which basically means this becomes 1 when you multiply these together. So the real answer is simply 84 times negative 8. This is going to yield negative 672. This is a term in the expansion. It's also a constant because it doesn't have any variables, and that's why it's the constant term. It's actually the answer to the question. So this is your answer for number 2. All right, and let's move on from there. Let's see if I can turn this page. Boom. All right, awesome. Number 3, this is a vector question. You will get a question very similar to this on the exam, as it's already been made. I will tell you that up front. In this question, distance is in kilometers and time is in hours. A balloon is moving at a constant height. Okay, constant height, that's important. It means it's not going up or down. It's staying at a level height above the ground, and it's moving, which means it's probably moving horizontally with the speed of 18 kilometers per hour in the direction of some vector. Okay, so usually we have a starting point of some sort. Okay, some starting point vector, and then we're going to add time times some sort of directional vector, which is actually right here. They're giving me this directional vector. It tells me at time 0, though, the balloon is at point B and has its coordinates. And then they say, show this vector B of the balloon is given by this time. The position of vector B right here. So basically, if this is 0, like they're telling me, time is 0, this is 0 times this vector, which is nothing. What's all that's left is 0, 0, 5, which is why they tell me the starting point is 0, 0, 5. However, to show this, remember they gave me a directional vector, and this is the starting point, and this is the directional vector, or a scalar multiple of it. So if I multiply this particular, this is actually a velocity vector, times time, it should equal the directional vector. These are scalar multiples of each other. So let's prove this. I'm going to say, okay, 340 is in fact equal to some value time times 10.8 times 14.4 and then times 0. So what I'm telling you is that 10.8 times t is equal to 3. Okay? So what I'm going to do then is I'm going to prove this. I'm going to say, okay, t then is equal to 3 divided by 10.8. And that should be, I believe, 2.7, if I remember. Okay, and this should be true for the rest of them. Okay, if I multiply 14.4 times 2.7, it should give me 4. All right, and then 0, of course, times 2.7 is still 0. That would prove this. This would be adequate. Another thing that you might want to consider is this is a velocity vector here. And if you take the magnitude of this vector, it's equal to the speed of the balloon. They tell me that the speed of the balloon is actually what? 18 kilometers. So this is actually, the magnitude of this vector is actually the same thing as 18. If you can show that, that would be fine. Okay, we say speed, right, which we know is 18 kilometers per hour. It's actually the same thing as the square root of 10.8 squared plus 14.4 squared plus 0 squared. Okay, you could show this as well. This would be adequate for me, but I'd prefer you go with this one. Just show me that this value of t is the same for every one of these 3 equations, and it's the same, and it'll be true. Okay, interesting question. Now at time 0, a helicopter goes to deliver a message to this balloon that's up in the air. The position vector h of the helicopter is given by this, so we have a similar thing as the balloon. Write down the coordinates of the starting position of a helicopter. The starting position of a helicopter is where t is equal to what? 0. That's the starting position. You see this right here, this value of t? If this were 0, then this is basically 0 times what? All 3 of these things. Which means this whole thing would what? It would go away. So what is the starting point? Really, it's just this. That's all that you would have left. It's just going to be 49, 32, and 0. That's a very, very simple question. Okay, now they want you to find the speed of the helicopter. Okay, recall then that the speed is the same thing as a velocity, and a velocity is actually the change in position over the change in time, or delta position over delta time. Now, if I actually go through and multiply both sides of this little equation here by time, this and this will cross out, then basically velocity times time is equal to your position. What do you think is happening here? This is a velocity vector, and we're multiplying it by what? Yeah, we're multiplying it by time. That's what's happening here. Same thing is happening here. Okay, so this is your velocity vector, and to find the speed, we just have to take the magnitude of this velocity vector. So that's straightforward, I think. So we're just going to do that. All right, speed for this helicopter, at least, is equal to the square root of negative 48 all squared plus negative 24 all squared plus 6 all squared. And then we're going to take the square root of that. Okay? What you're going to find if you work this out, I would suggest with a calculator, is this should be around 54 kilometers per hour. That's how fast the helicopter is moving. That's not an unreasonable speed for a helicopter, as long as it's not trying to set any speed records there. So the helicopter reaches, let's go to the next question. The helicopter reaches the balloon at point R. Find the time the helicopter takes to reach the balloon. Well, this is the least fun part. We actually have an equation for the balloon and an equation for the helicopter, and we have to set these two equations equal to each other so that this coordinate and this coordinate are the same. That's where they intersect or collide. So let's do that. Let's try this. 0, we're going to go with this one here, 0, 0, 5, plus t times this. I'm going to write that first. All right, so let's do that. All right, so 0, what's right here? 0, 0, 5 plus t times 10.8, also times 14.4, and times 0. It's going to equal the equation for the helicopter. What's the equation of the helicopter? I forget. It's this right here. It's going to be 49, 32, and 0. All right, so here we got 49, 32, 0. We're going to add t times this, and this is going to be negative 48, negative 24, and 6. Presumably, though, that the value of t is the same for both of these, so that's why they're both called t. Typically, you would change them just to be on the safe side. Students have asked about that, but in this particular case, it works out either way. If you want to call this t something else, like p or w, that's fine, but you're going to find that this value and this value actually will be the same for both equations either side. It doesn't make any difference. So I'm just going to look at the bottom equation to solve this value for t. I got 5 plus t times 0, which is basically 5. And this is equal to 0 plus t times 6, or 6t. Okay, that means t is equal to 5 over 6, and that will be in hours. So here's your value for t. 5/6 of an hour, or you can say this is actually about 50 minutes is really what it is. Okay? So that's the time. It takes 50 minutes for the helicopter to reach the balloon. Find the coordinates of r. All right. So now that I have 5 over 6 as t, because t is in hours, I'm going to plug 5 over 6 into this value of t. Or I can plug it into here. It doesn't make any difference. You'll get the same r value either if you use this side or if you use this side. All right. So I'm going to plug that in here, into here. This is going to be 5 over 6. We're going to plug it in. So what I have is basically 0 plus 5 over 6 times what? 10.8. Alright, and then I got 0 plus 5 over 6 times what? 14.4, and 5 plus 5 over 6 times 0. Okay, this is going to give me 3 different numbers, and I don't recall, I believe this one, of course this is obviously 5, this is 0 here, right? And then we got this, I believe this was 9, 12, and 5, if I remember from class. I've done this a couple of times. So that should be your answer, or somewhere thereabouts. That's the actual coordinate of r right here. So that's your answer there. And then we're going to move on to the next question. Number 4. That's always fun. The first 5 terms of an arithmetic sequence. Arithmetic sequence means common difference. Okay. We're just adding the same number over and over again. So I see 2 plus a number equals 6. That number is quite obviously 4. 6 plus 4 is 10. 10 plus 4 is 14. 18 plus 4 is 18, and so on. Write down the 6th term. Well, we got 1, 2, 3, 4, 5 terms. So we add 4 more to this. This should be an easy 22. So this answer is 22. Okay, that's the sixth number. We could also call it A6. That's the sixth term. A6 is equal to 22. And that's your answer for this question. Okay, arithmetic sequences only have really two formulas that you need to worry about, and here's what they are. I'm going to write them right here for you. I'm going to say AN is equal to A1 plus N minus 1 times D. Right? That'll tell you any term of an arithmetic sequence. The sum formulas for a finite sum, this is different. Sum of n terms of arithmetic sequence is given by this. We actually call it an arithmetic series when we add all the terms together. It'll be given as n over 2. And then plus the first term, n over 2 times the first term, plus the very last term. Okay, so these are important formulas to know for arithmetic sequences only. Calculate the 200th term. So I want A200. I want the 200th term. So this n value right here, they're telling me is what? They're telling me it's 200. So this will equal the first term. The first term I know is what? Is 2. 2 plus, we know this is what? 200. 200 minus 1 is 199, and then we'll multiply by the common difference, which we decided up here is 4. Alright, so 4 times 200 would be 800. We subtract 4 from that, which would be 796, and then we'd add 2. So this answer would actually be 798 when you figure it all out right here. Alright, and then we're going to move down, and we're going to find, of course, the sum right here, the sum of the first 90 terms. So, okay, so the sum of the first 90 terms is equal to 90 over 2. Remember, n is 90. That's what they're telling me. And this is times A1. A1 is this number right here, which is 2, the first term, plus A90. The problem with this term being A90 is I actually don't know what it is yet. I have to figure this out. What is the last term if there are 90 terms? What is the very last one? It's the 90th term, and I have no idea what it is. But I'll find it using this top formula again. Okay, so we say A90 is the first term. First term again is what? 2. Okay, plus 90 minus 1. N is 90, so this is going to be 89 times D, which is the common difference of 4. If this were 90, if I add one more to it, this will be 90 times 4, which is 360. Then I'll just go ahead and take 4 away, and that's going to give me 356, and then I'll add 2. This is actually the same thing as 358. That's what I'm going to add right here. It's going to be 358 that I'm adding right here. Alright, so let's go through this. This is going to be 90 divided by 2. Most people call that 45. And then we got 358 plus 2, which is an even 360. Multiply these together, and then that sum of the first 90 terms should equal about 16,200. And that would be your solution for this one. Okie doke. Let's move on to the geometric sequence. Alright, the geometric sequence is a little trickier because there's more formulas that go with it. And let's go ahead and write these over here in the margin first before we even start this, because you need to see all these formulas. To find any term, we'll say AN. The nth term of a geometric sequence is given by the first term, A1, times the common ratio raised to the power of n minus 1. Okay, that's a very important formula. We'll do the finite sum formulas. There's 2 of them. It depends on the value of r, which one you use, but here they are. We could say sum of n terms will be given as A1 times 1 minus r to the power of n all over 1 minus r. This is true if in fact the value of r, or the absolute value of r, is less than 1. So this is a common formula to use. If the value of r is not less than 1, at least the absolute value of it, then we're going to say we use this formula instead, which is kind of the same thing, but we're going to rearrange some things. This will be r to the power of n minus 1 all over r minus 1. And that's true if the absolute value of r is greater than 1. So there's two different formulas based on the value of r. There's a fourth formula if they ever ask you for the sum of an infinite geometric series, which is not what's happening here, but just in case so you know, it's going to be A1 over 1 minus r. This is only true if the absolute value of r is less than 1. That means that an infinite sum would converge to a single value. If r is greater than 1, it would go up to infinity, so there's no point in trying to calculate it. Okay, so let's find the common ratio of this. They're kind enough to give me some information. We can get this started now that I have all this written. So I'm going to say, all right, A1, the first term is 7, because they've told me so right here. All right, the third term is 28. That means A3 is 28. All right, so now I'm going to go ahead and utilize this equation right here to actually try to do something here to find the common ratio. I'm going to say AN is the same thing as A3, so I'm calling N3. So A3 is 28. That's what I'm going to start with. A3 is 28. This will equal the first term, A1, and A1 I know is actually 7, times R. I have no idea what R is yet. Raised to the power, remember N is 3, so this is 3 minus 1, which is actually squared. So now I can try to solve this equation. I'll divide both sides by 7. And I'll say 28 over 7 is 4. So R squared is equal to 4. That means R is either equal to what? Positive 2, or it's going to equal negative 2. These are your possibilities. If this were negative 2, and I kept multiplying terms by negative 2, they would alternate between positive and negative terms over and over again. This is not what's going to happen here. I don't really care about this answer because it tells me that all the terms are positive. So this is the only one I really care about. This answer is actually just 2. That's the solution for the common ratio. That's 2. Now they want me to find the sum of the first 14 terms. Well, this value of R is greater than 1. It's 2. So I'm going to look at this equation right here that says R is greater than 1. I'm going to ignore this one, and we're going to use this one right here. That's the one I want. So they tell me the value of N right here is 14. So this N right here is also 14. Sum of 14 terms is equal to the first term. Recall that the first term they give you is 7. We're using this right here, first term, times R, which I now know is 2, raised to the power of N, which they told me is what? 14, minus 1, all over 2 minus 1. That's the value of R, 2 minus 1. Well, 2 minus 1 is 1, so that bottom part doesn't matter much. It's just going to be 7 times 2 to the power of 14 minus 1. And this will give you, I believe, an answer. If I remember from class, you might want to check this. I think it's 114,681, I believe is what we got for that. So that should be your answer, I think, for number 5, part B. So go ahead and check that, I guess. And then let's go on to number 6. Alrighty, no problem. Number 6 is a derivative function. Okay, well, it's not a derivative function, it's just a function. We're going to find its derivative right here. So what's the derivative of this function? Okay, just take the first derivative, which is a calculus concept. This is going to equal 3x squared plus 12x plus 12. If you don't know how to find a derivative, then you really need to pair up somebody in class and ask them, because this has been gone over several times. Alright, we've done this in class several times. You can look up how to find first derivatives of polynomial equations on the internet if you're not sure, but I'm not going to explain it. I'm just going to show you this is what the answer is, okay? All we're really doing is multiplying the exponent by the coefficient and then taking one away from the exponent when we're done, okay, for each particular term. So that's that. Now they want me to take this derivative that I just found and they want me to set it equal to 0, okay? This begs the question, why do I do this? Okay, now let me go back and explain this. It's important that you know, if you have a graph that looks something like this, okay, derivatives, what this derivative is actually the slope of a tangent line to this graph, and there could be billions of tangent lines. This is a tangent line, this is a tangent line, this is a tangent line, and so forth, right? But the tangent lines at local extrema, be it maximum or minimum, they are horizontal lines and their slopes are equal to 0. Okay? Since this is a slope of a tangent line, okay, and I want it to be 0 because that's what they're telling me to set it equal to, what this is going to tell me basically is the x value, if I solve it for x, the x value of these local extrema, either it be a maximum or a minimum. So let's go ahead and do this, okay? I want to go ahead and solve this, so what I'm going to do is set this derivative equal to 0 and solve it for x. Okay, so that's what they're asking me to do. So I have 3x squared plus 12x plus 12 is equal to 0. I'll go ahead and factor out a 3. So this will give me x squared plus 4x plus 4 is equal to 0. And now I'm going to factor this, okay? We should see then that's the same thing as 3 times x plus 2 times x plus 2, and that's equal to 0. If we set these factors equal to 0, we can figure out this x value. So this one's going to be x is equal to -2, because -2 plus 2 is 0. But so is this one. All right, this is the same answer, so we only need one. This apparently is where the maximum or minimum is going to occur. Okay, so let's go ahead and calculate the values of g prime when x is -3. All right, keep in mind, this is g prime up here. We found it. They just want me to plug in the value -3 into what? Into these x's right here. So I'll do that obligingly. So I'll say, okay, g prime of -3 is actually equal to 3 times -3 squared plus 12 times -3 plus 12. This will be 9 times 3, which is 27, minus 36 plus 12. 27 minus 36 is -9 plus 12. This will equal 3. All right, so that's the answer for this question. Now they want me to plug in 0. Okay, so for the same derivative, I'm going to plug in 0. If I plug that in, I'll get 3 times 0 squared plus 12 times 0 plus 12. Remember, I'm plugging it back here into the derivative. This is nothing, so this answer will be 12. That's the solution for this one. This is actually, what did we find here? What we found are slopes of tangent lines, okay? These are slopes of tangent lines. Remember, these are slopes, okay? If you have a graph and you have a point here and there's a tangent line and its slope is positive, just like it is here, because this is a positive number for the slope, what does it mean about the graph? I mean, at this point, it means the graph is actually increasing, okay? When you get a negative number out of this, that means the graph would be decreasing somewhere. So these are both positive, because my answers are 3 and 12, and they're going to ask me, what's this graph doing? Well, at -3, because the slope there is positive for the tangent line, this graph is increasing. Okay? They just simply want me to tell you if it's increasing or decreasing, and this is quite obviously increasing. At x equals 0, this is 12, which is also positive, so this is also increasing here. It's increasing for both spots. All right, so that's all it is for that question, not much to it. Let's move on. Number 7. This is going to require a bit of work. Okay, it's one of the trickier problems that we have, but let's go ahead and do it anyway. We have a solid glass pyramid, okay, given all these vertices labeled with these capital letters. The base of the pyramid is a square of side 3.2 centimeters. 3.2 centimeters, and so is this one, just for giggles. And they're going to tell me, of course, the vertical height is 2.8, and V is directly above 0.0, the center. That drawing is terrible. Look at that. I can't even draw a straight line. This right here, this distance is 2.8. So just, yeah, I really need to get the eraser out. It's kind of embarrassing. I can't draw. Alright, so let's just erase this whole thing again. Good grief. Alright. And let's get this pen going, and we'll try this again. So yeah, there we go, much better. So we got that. It says calculate the volume of the pyramid. All right, no worries, no step for a stepper. Volume is 1/3 the area of the base times the height of the pyramid. So it's 1/3. The area of the base is 3.2 times 3.2. So 3.2 all squared times the height, and the height we decided is 2.8. Says so in the question. And this should be something around, if you use your calculator, 9.56. And that will be in cubic centimeters. Okay, that's the answer for that. It's a volume after all, so cubic centimeters. Now they're going to come around and tell me that the glass, since this thing is a pyramid made out of solid glass, the glass weighs 9.3 grams per cubic centimeter. Calculate the weight of the whole pyramid. I know the number of cubic centimeters, I know the weight per cubic centimeter, so you just multiply 9.3 times 9.56. 9.3 times 9.56 is somewhere around, I believe what we said was 88.88 or 89 grams is what this is going to be. That's how much this pyramid weighs in grams, so that's about the answer there. Show that the length of the sloping edge VC of the pyramid is 3.6. I love this question. Okay, So here's the sloping edge VC from V all the way down to C, and they want me to show that this is 3.6, supposedly. All right. So how we're going to go about doing this? Let's see if I can change my pen color here, if you don't mind. Yeah, red's a good thing to go with here. So I look at this square base, and I got this base, and I got this here. So I got this side and this side. It's a square, and there's a diagonal going from one point to the other. Since I know this is 3.2 and this is 3.2, and I can also say this is a right triangle because it's a square, I can actually use the Pythagorean Theorem to figure out this unknown distance from A to C. Okay, so I'm basically telling you is that AC squared, that distance, is given by 3.2 squared plus 3.2 squared, using the old Pythagorean Theorem. Alright? That means that AC is equal to the square root of all this business right here, which is actually the same thing as a distance formula. And then we got this here. Alright. That'll give me the entire length from A all the way to C. So let's change the pen color again. I'm just going to keep doing this. So that'll give me this whole thing. Alright. I don't really want to know that, though. I don't really want to know what AC is. I just want half of it. Okay, I only want half of it. I only want this part right here, just this half. Because if I could just get this half, I can create another right triangle that goes down from here, down this way, and this is a right triangle this way. So if I just had this particular length right here, that would be enough. So I just need to figure out what this is and then cut it in half. Okay? And then I'll have this distance squared times 2.8 squared, and that'll give me this unknown side, which I'm going to say should equal 3.6. So let's go ahead and use my trusty dusty calculator, and I'm going to go ahead and figure out what this whole diagonal is, and then I'll cut it in half and figure out what half of AC is. Alright, let's do that. Alright, so let's create a new document, don't save any stuff. Alrighty, so let's take the square root of 3.2 squared plus 3.2 squared. And this is going to equal that. Okay, that's the distance AC. I'm going to divide this by 2, and that'll give me 2.26. That's the value right here. So let's go ahead and go back to the drawing. Alright, so control square root. We're going to say 2.8 squared plus 2.6 squared. I'm sorry, not 6. That's wrong. 2.26. Oh, I've been messing it up. 2.26, alright. Squared, this should equal 3.6-ish. And that's what it is about. It's about 3.6. So let me go ahead and fix. So we're going to say, again, VC is equal to the square root. We're going to say this is actually 2.8 squared plus 2.26 squared, or somewhere thereabouts. That's about equal to 3.6, and that is true. That's in centimeters, mind you. So that's that answer shown. You really just have to show all that work for this question is really what they're doing here. Alright, so sorry for all that. I get to D here, calculate the angle at the vertex of BVC. Alright, I got a lot of stuff, a lot of mess here. I'm going to actually erase some of it to make this a little more concise, a little clearer. So let's pull out this eraser here. No, I don't think that worked. Yeah, here we are. And we're going to erase some of this stuff that we've made here. And I'm going to go back over it with my blue pen. I guess blue pen's good. Yeah, I'm all about that. Alright, so let's imagine we have a thing going on here. We got this triangle, right? We got a triangle here, all the way down, all the way down. And what this question is asking me about is this angle BVC. That's what this is asking me at that vertex. So if I go from B to V, so from here to here, back down to C, the angle they're asking me, the angle in question is this angle right here. What is this angle? What's the value of this angle? Okay, well, that's no problem because I know this distance here is 3.6, and so is this edge right here. It's also 3.6 because it's a pyramid. I also know this is 3.2 at the bottom, so I know all the sides of this triangle. If I know all the sides of the triangle, I can find any angle utilizing what is called the law of cosines. All right. So if you guys remember the law of cosines, I'm going to get a black pen here. Alright, this is what it is. It's a squared is equal to b squared plus c squared minus 2bc times the cosine of a being the angle. Alright, so I'm going to call this angle A right here. And the side opposite of that will be little a, right? Oops, let's see here. Alright, so what we're going to do basically is we're going to solve this equation for cosine of a. What I was saying here though, okay, so what I'm looking at here is that this is a, and the side opposite that, we'll call this little a, okay? This is the length right here, opposite the angle big A right here. So I could call this angle B and C if you want, big B, big C, and then the side opposite the big C will be little c, and the side opposite big B, this will be little b. Either way you want, okay? And we're gonna rearrange this equation and solve it for cosine of a. So let's just do this here. That means cosine of a has to be equal to a squared minus b squared minus c squared all over negative 2bc. Okay, this is true. And then to find a, I'll take the cosine inverse of both sides of this equation. Okay, so that means that a, angle A itself, is actually just the cosine inverse of a squared minus b squared minus c squared all over negative 2bc. And since I know the values of a, b, and c, I could actually figure this out with a calculator. Okay, so what this really means is this is the cosine inverse of 3.2 squared minus 3.6 squared minus 3.6 squared over negative 2 times 3.6 all squared, because it's 3.6 times 3.6. So they're the same. Alright, so let's just get the calculator, tell me what this is. Alrighty. So we're going to go, make sure this is in the right mode. I'm going to go to dock settings, and make sure it's in degrees, and it is, so that's fine. Alright, so I'm going to go to dock cosine inverse, control divide, let's make this fraction. Alright, this is going to be 3.2 squared minus 2 times, since there's two of them, 2 times 3.6 squared divided by, okay, negative 2 times 3.6 squared again. I'm going to actually put this in parentheses. It may not be a bad idea. And then I'll close it up, and then I'll square that guy. And then we're going to figure out what this is. This is going to be that. So this angle is about 52.78 degrees if you're rounding to the hundredths place. So this answer is about 52.78 degrees. Is that what it says? I think that's what it said, right? Short-term memory is not so good. So we're going to say then this is going to be BBC, this angle, if you want to find it, is going to be 52.78 degrees about. Alright, calculate the total surface area of the pyramid. That's the final question, thank goodness. Total surface area, this thing is made out of glass. If you were to dip it into a, I don't know, a bucket of paint, how much surface area would you cover with the paint, for instance, right? So that's what we're trying to figure out. Let's get this eraser going here. I need to clear up some space because I got to be able to see stuff on my diagram here. I'm just going to erase everything, so hope you wrote that somewhere. Alright, and then we're going to get back to work on this. So let's get this pen, let's use colors that rhyme with purple, I guess, here. And then let's find this here. To find the surface area, I can see quite obviously that there are a bunch of triangles. I got a triangle here. Perfect drawing, look at that. Nailed it, right? Got a triangle here. And how do you find the area of a triangle? The area of a triangle is given by 1/2 base times height. Now, I know the base is 3.2, and I also know these side lengths are 3.6. Not that that helps a whole lot. But I know the base. I need to know the lateral height of this triangle. So what's useful to know is that this height right here. I know this height right here is 2.8. They told me that in the question. So this is 2.8. This height right here. And this distance here is half of this side, which is 3.2. So half of 3.2 is actually 1.6. I know this distance right here is 1.6. I know this is 2.8. And I have a right triangle built in here. So now I can find the lateral height of this particular triangle here using the Pythagorean Theorem. Okay, so this height is going to equal the square root of 1.6 squared plus 2.8 squared. As it turns out, ironically, that height is going to be 3.2, which is actually the same thing as this. Okay, it is 3.2. So what I'm going to say then is that this area of one face, right, for that triangle, the area of one face is going to equal 1/2 3.2 times 3.2, or 3.2 squared. We have 4 faces like that, though, so we're going to have to multiply this by 4 to account for every triangle. Keep in mind what I'm talking about is I have a face here, and a face on the back, and a face here, and all that good stuff, right? So we have 4 of them. So if I multiply 4 by half, what I actually get is 2. So I got 2 times 3.2 squared, which is basically all of the triangles. But one part I'm forgetting for the surface area is I'm actually forgetting the area of the bottom of the base. We have to add that to the area of the triangles. And that's going to be a square. So it's going to be 3.2 squared again, because it's a perfect square. And what I notice is that I have one 3.2 squared, and I have 2 of them right here. So let's add them together. And that will give me 3 times 3.2 all squared. This is going to give me the total surface area of the whole thing. Alright, so I'm going to say 3 times parentheses 3.2 squared. This will equal 30.72, and that's actually the surface area, 30.72 square centimeters. That's the surface area for the entire pyramid. And that's your answer for this. Kind of a long-winded question, but it's important to know all these steps here. Let's go on to the next question. Okay, verify, prove the following identities. All right, these are tricky only because you may not know all of your trig identities. I'm going to give you several of them for the test. I'll give you all the necessary ones anyway, and you have to know how to use it. To verify a trig identity, basically you manipulate one side of the equation and try to make it the same as the other side. Only use one side. My recommendation, although you don't have to follow it, is that you pick the complicated looking side and try to make it look like the other side. Okay? I know for a fact, though, that secant 2 theta, I'm going to go ahead and tell you right now, I know that secant 2 theta, I'm just going to say this I want you to see this. Secant 2 theta, guys, is the same thing as 1 over cosine 2 theta. Alright? Secant is a reciprocal function of secant, or reciprocal function. So this is the same thing. I also will tell you that the cosine of 2 theta is actually the same thing as cosine squared theta minus sine squared theta. This is just food for thought, alright? So this is just food for thought right here, and we're going to ignore this for now. Okay? All I'm going to do now is really mess with this and try to make it look like this side now. Okay? This is just some stuff here that we did for our reference. So let's take a look at this. I'm going to take the right side and make it look like the left. So we got secant squared theta over 2 minus secant squared theta. It is worth noting your Pythagorean identities. There are 3 of them. We know that sine squared theta plus cosine squared theta is equal to 1. Very famous identity, that one. Also know that 1 plus tangent squared theta is in fact equal to secant squared theta, another famous one, and that 1 plus cotangent squared theta is equal to cosecant squared theta. That's the third. Alright, I see secant squared theta right here on top, and I know that's the same thing as this, so I can rewrite it as being that. Okay, I can actually say this is 1 plus tangent squared theta on top, And then what I have here on the bottom is 2 minus 1 plus tangent squared theta, because 1 plus tangent squared theta is the same thing as secant. I just told you that right here. Alright, so we're going to move from here down to this way. I'm going to convert everything into sines and cosines. This is not a bad trick if you ever get stuck on a problem like this. Alright, so I know that for a fact that tangent squared theta is actually the same thing as sine squared theta over cosine squared theta. Right? This part right here. I'm adding 1 to it, and 1 can be written as many things. In this case, I'm going to write it as cosine squared theta over cosine squared theta. Most people don't dispute that's the same thing as 1. And that's actually the top part of my problem right here. Bottom, we're going to do some things here. Okay, I got 2. I'm going to distribute this negative. So 2 minus 1 is 1. And then we got negative, what? Tangent squared theta. That's actually what this is right here. Okay, so we're going to do the same thing. Tangent squared theta is the same thing as sine squared theta over cosine squared theta. And 1 can be written as cosine squared theta over cosine squared theta again. Okay, now keep in mind when I do this, I have a common denominator, so I have cosine plus sine. Cosine plus sine squared, cosine squared plus sine squared on the top. Cosine squared plus sine squared is actually the same thing as 1. So that's another identity that we're using. And we have a common denominator, excuse me, of cosine squared theta. So that's going to be right here. This is the top portion of my fraction. Here I got a similar thing going on, except there's not much I can do to consolidate it. I'm just going to have to say simply cosine squared theta minus sine squared theta all over the common denominator of cosine squared theta is what I have here. When you divide by a fraction, we multiply by the reciprocal of this fraction. So we're going to multiply this top part by cosine squared theta over cosine squared theta minus sine squared theta. What's going to happen is that this and this are going to cancel out, and then I now have 1 over this. I now have 1 over cosine squared theta minus sine squared theta. If you look at this part on the bottom, you should recall that I wrote up here for my reference, that's the same thing as cosine 2 theta. That's another trig identity. So this is actually the same thing as 1 over cosine 2 theta. And that's actually the same thing if 1 over cosine is the same thing as secant. So now this is the same thing as secant 2 theta. This right here is actually what I wanted it to be in the first place. So this is now all of that work for that. Okay, that's the answer to this question. And you'll have one similar to it on the exam. And hopefully you don't have as much trouble with it, because I think it's going to be a little interesting. So we'll see what happens. So I'm going to go on to the next question. I really want to erase some of this mess that I've made right here and go through this here. This is big mess. All right, so let's go back. Let's do red, I guess, here. And now we're going to use what is called a half angle identity for tangent x over 2. All right, so just pause that for a minute. All right, so let's write some reference material here. I think this should say equals, because that shouldn't be minus. It should say equals. Doesn't make sense for it to say minus. We have to show that this side and this side are the same. All right, I'm going to actually work with this side first, because I know this trig identity. The tangent of x over 2, if you want to call it that. Okay, this can be written in a lot of different ways. This is the same thing as 1 minus the cosine of x, okay, over the sine of x. Or we could say that's the same thing as the sine of x over 1 plus cosine of x. Either way, this is the same, okay? So let's take this into consideration. I'm going to look at this one right here, since I know this identity, right? This is going to be split into 1 over what? Sine of x minus cosine x over sine of x. This is a real easy one. And 1 over sine of x is the same thing as cosecant x. And then cosecant over sine is actually the same thing as cotangent x. And this right here is actually what you wanted it to be to begin with. So that is really easy in comparison to one previous that we just did. And then we're just going to move on from there. This is number... Okay, so we have number 10, find the acute angle formed by two lines. Okay, so there's two lines and they make an angle. So we're going to go ahead and figure out what that is. I'm going to use vectors to do this. I'm going to create vector equations for both these lines. Alright, so all I really need for this is a point and a direction. Point and direction for both. Okay. To find a point, if I were to plug in 0 into this value for x, then this will be 0 times a third, which is 0 plus 1. So the point will be 0, 1. The direction is the slope, okay? Except we're going to take this slope, these two numbers. This is basically, we know from a slope of a line is delta y over delta x. So this is a y value, this is x, this is a y displacement, that's an x displacement. We're just going to flip these numbers upside down to find a directional vector. So this one will be actually 3, 1. Okay, because here x is on top and y is on bottom. So what I basically have here is a vector equation of a line. It's written as the point 0, 1 plus some sort of scalar, we'll call it p, I guess, and then we'll say times the vector 3, 1. So that's a vector equation of this line. We'll do the same thing for this one. I'm going to do a point as well. Let's go ahead and write this all out. And I like the point 0. If I plug in 0 here, I'll get negative 3 for y. And then I'll do the direction again. And that will be the reciprocal of the slope here. Now, keep in mind we're saying this is negative 1 over 2. So this is going to be 2 and negative 1. Technically it would be the same thing. Alright, so what I have here is another vector equation where I have 0, negative 3. And then plus a scalar 2, negative 1. Now, this point, initial point, doesn't really interest me to solve this question. I don't really care about these directional vectors. So what I'm going to do basically is do a dot product of these vectors and use that to find the angle. Okay, so the dot product of this vector and this vector, we'll just go ahead and write it like this. Say 3, 1, dot 2, negative 1. And this will equal 3 times 2 plus 1 times negative 1. Okay, that's that dot product. Okay, and this is going to equal something. And this is going to equal 6 minus 1, which is 5. That's what this is. Keep in mind that the dot product has a formula. The dot product of two vectors, let's say these vectors are a and b, is equal to the magnitude of a times the magnitude of b times the cosine of the angle between them. So it stands to reason that the cosine of theta is the dot product of these two vectors divided by the product of these magnitudes that they have. So that's fine. I just found the dot product right here. I know this to be 5. That's what I discovered right here. But I now have to find the magnitudes of both the vectors, which is okay, no problem. So let me extend this page a little. And I'm going to do this here. I'm going to say, okay, the magnitude of this one right here, this vector right here, is going to be the square root of 3 squared plus 1 squared. Okay, so it's the square root of 10, basically. And this one right here is the square root of 2 squared plus negative 1 squared. And that's going to give me 4 and 5. So this is the square root of 5. So what I really have here is the cosine of theta is actually equal to 5 over root 50. So basically, the cosine inverse of 5 over root 50 is equal to the angle that I want. This will give you the answer. So let's go ahead and use a calculator to figure this out. And then I'll say cosine inverse control divide 5 over root 50. And that'll be 45 degrees. That was the answer to that question. So this angle between these two is 45 degrees. Alright, that's really nice. So that worked out nicely. That's that answer. I think this review is done now, so hope you look over this, and good luck to you on your final. And yeah, keep studying. Bye-bye.